In today's video, I'll be teaching you how to rationalize the denominator. So in the given expressions, the 1 over x is said to have a rational denominator. Why? Because the x is just x. And in this second expression, you have 1 divided by root of x, and it is said to be irrational. Can you see the difference? Difference is that this one is just x, and this one, its denominator, is just root of x. So the main idea of rationalizing the denominator is making sure that you are moving from a denominator that has a square root to a denominator that doesn't have a square root. So most of the times when you are rationalizing the denominator, you'll be moving from a denominator that has a square root and to a denominator that doesn't have a square root. So for example, if you have 1 divided by x plus 1 and also 1 divided by the square root of x plus 1. So the idea is this one is irrational, or it has an irrational denominator, and this one has a rational denominator. So to rationalize this denominator, you'd want to remove the square root in a way that you would have something that doesn't have a square root in the denominator. So that is the main idea of rationalizing the denominator. So what tools do you need to actually rationalize a denominator? So I'll be teaching you 2 things that you can use to rationalize almost all the denominators. The tools needed for rationalizing the denominator are 2 mostly. And the first one is you have to multiply the given expression by a special one. You'll see when we do the examples what I mean by the special one. So the second one is if the denominator is a binomial, then the special one should be a conjugate expression. Don't worry about all these terms. I will explain what they all mean. So now let's first talk about the first one and see what I mean by the special one. Let's say you were given the expression 1 divided by root of x, the one we had before, right? So I'll just underline here. If you were given 1 divided by root of x and you were told to rationalize the denominator, what I mean is you have to multiply this expression, this whole thing is called an expression, by a 1. So, but this 1 is special because remember that 1 can be anything divided by itself. So this means that you can turn this expression into something like 1 divided by root of x multiplied by root of x divided by root of x. This now is our 1 that we're multiplying, and it is a special one because you are taking the denominator itself and you are multiplying by itself divided by itself. So that is a special one, right? So this then will give us 1 divided by root of x because we're multiplying. Then this will be 1 divided by 1 multiplied by root of x, and also the denominator will now be multiplied by root of x, and now we'll have 1 multiplied by root of x, that will just be root of x. Root of x multiplied by root of x, the square root cancel out, and we're only left with root of x divided by x. And this is now a rational denominator. Now this has a rational denominator. So the idea was to multiply this expression by a special one. And how do you get that special one? You look at the denominator, and if it's just a single term, you just take that denominator and then you divide it by itself, and then that is your special one. And then you rationalize your denominator just by doing simple algebra. Right. Now, let's just do another example. So another example of the special one case, let's say you have 5 plus x divided by root of y, like that. So we say that you have to multiply by a special one, and that's just this. And this can be turned to 5 plus x divided by root of y multiplied by root of y divided by root of y, because root of y divided by root of y is 1. So this doesn't change anything. You're just multiplying by 1, right? So the numerator will be multiplied by y. So this will just be root of y multiplying 5 plus x. And root of y multiplied by root of y, the roots cancel out, and you'll be left with just y. So this now is how you rationalize a denominator that has only a single term in the denominator, right? So you multiply by a special one. Now, let's go to the second point that I talked about, that if a denominator is a binomial, then the special one should be a conjugate expression. So first we'll have to explain what a binomial is, and then we already know what a special one is, and then we'll explain what a conjugate expression is. So let me just erase this. So what is a binomial? A binomial just means an expression with two terms. So this means x plus y is a binomial. A plus b is a binomial because you have term number one, term number two, term number one, term number two. So what we're saying is if the denominator has two terms, for example, if you have 1 divided by x plus y, like this, or 1 divided by the root of x plus y, then the special one should be a conjugate expression. So now we already know what a binomial is, and we know what a special one is. Now, what is a conjugate expression? A conjugate expression is a binomial expression that has a different arithmetic sign to the original binomial. So what do I mean by that? So if you have x plus y, and then you're told to find its conjugate, the conjugate of x plus y is x minus y. This is the original, and then this is the conjugate of the original. So if you have a minus b, the conjugate of a minus b is a plus b. You're just changing the sign, the arithmetic sign that exists between the original expression. So in other words, if you have this and we are told to rationalize 1 divided by root of x plus y, we see that there is a square root in the denominator, which means the denominator is irrational. This means that we can use the second rule that we just established, right? So if the denominator is a binomial, and this is a binomial because we have term number one, term number two, then the special one should be a conjugate expression. And what is a conjugate expression of root of x plus y? That is just the root of x minus y, because we said we only changed the sign. And because it's a special one, we also need to divide this by itself because we want to multiply by 1. This then gives us 1 multiplied by root of x minus y. This doesn't change the numerator, so we'll just have root of x minus y divided by. So if you see, you have, okay, let me just write it in bracket form. So you'll have root of x plus y multiplied by root of x minus y. If you have been paying attention, you can see that this is a difference of two squares. This, because it's root of x plus y, root of x minus y, which means this can be written in this form. So root of x minus y divided by, so difference of two squares, what happens is we say we square the first, and then there's a minus, and then we square the second term. This is because if you have a squared minus b squared, this is a minus b, a plus b, right? So to move from this to this, you just square this one and put a negative and then square the last one. So what we're doing is we're squaring the first one, and then we're putting a negative and then squaring the second one. And then this is what we have. And then to simplify this, we'll have root of x minus y divided by root of x squared, that's just x, minus y squared. And then now we have a rational denominator that doesn't have any square root. And with these two rules or two tools, this is how you rationalize most of the denominators you will find.